So, hope y'all can y'all see my screen? Is the font too small? Or do I need to bring it up in size? That should work a little better. Okay, so this is the kind of tutorial of running a BOINC project, setting one up. Also, I've created kind of Ansible scripts, which are very much similar to Chef and things like that, where you're able to actually just run the script and have it go through and process on your machine. For the purposes of this meeting or this tutorial, the servers that we're using are Ubuntu 20.04 version 2 of that. And I'm assuming that you have it set up so that you can have SSH and you have a user ID and things like that associated already installed on the machine. So that's kind of the initial start of all of it. I'm hoping to share this with the BOINC community and have it uploaded on the BOINC GitHub so anyone can modify, tweak, and do whatever they need to with this. But for now, it's just on a private repository that I've created. I did this very similar to the last BOINC workshop. However, on this one, I'm running version 20.04 instead of 18.04. There are some changes, meaning Python 3 and things like that, that I had to tweak a little bit for. So the README has a real quick information about what you need to do on the machine. Like I said, after the machine is installed, you'll just run a couple of commands here. One of them, you'll have to install Ansible, Git, and OpenSSH server, VIM. I only have VIM because I like to use it when I'm in the machines editing files. So anyways, these two steps have already been done I've already done that in preparation for this. So the last step here that I need to do is just run this Ansible setup server. So for Ansible, there are certain things. You set up a YAML file and it has a whole bunch of roles that you can run and packages that you can do and things like that. So inside of it, I have the certain roles or packages. So I'll install the base information that's needed to compile and do everything with BOINC. I'll create a user called BOINC on the systems so that way it's consistent, you know what's created, permissions are correct. Then I'll actually go in, it'll compile or download the latest version from the Git repository and install BOINC on the system. It'll set up MySQL, and then what it does is it does the make project command, which for BOINC actually does the inserts into the database and creates the database structures that are needed for BOINC to operate properly. And then I have an optional step here called BOINC attach. On these machines, I install BOINC also, so that way we can use it as an all-in-one testing environment. And then the last part here is copy files. These are the example, like I've gone into more detail on the validators, the simulators, and how those kind of work, and you can kind of mess with those and you can modify them a little bit differently. For this, I tried to move to CMake 3 for a lot of these interactions with the compiling of code. The reason why is CMake just is a lot more powerful, easier to manipulate and use. So for someone who wants to create an assimilator or a validator for BOINC, they should be able just to easily edit the CMake list file and just recompile pretty quickly and easily. It's to simplify things. It's to make life easier for people. So the benefit of all this is that I've already done the 2 servers that I posted in there. Oops, wrong file. Where am I going? I've already set up the 2 servers, BOINC 11 and BOINC 12. So, and I actually set up BOINC 10. That one's the one I'm going to be using. So in the Ansible script in here, oh wait, I've got the wrong IP address. Hang on. 1 second. This is what happens when you try to test things live, or you test things just relatively recently. So I will go in, and so for this, for Ansible, I just modify this remote.ini file, which has some of the defaults of things that I have set. Like I have the project name as test project 13 or 10 or 11, whatever your server you're on. I put in the host name and then also the IP address and things like that. It's very simple. The BOINC password is created using make password. And then I just use the hash in there so I can actually insert it properly into the system, and has the salt and everything already done there. So, and then I got fancy with mine, and all three of the servers 10, 11, and 12, those three servers are actually attached to each other. The BOINC clients are, so each one of those acts as an individual host within the servers. So, and one thing to note here also is that I'm using the server branch 1.2, which is the latest server branch release for BOINC. And so that's where you can set the branch of what BOINC, which version you want to compile. You can change that to master if you want, or whatever version. I do know that 1.2 works well, except for the Python 3 part, which I made an amendment to that, but it does work and run very stable. So let's see here. So then all I have to do after doing that to set up a new server, oh, there it is to run this Ansible command. In the README file, I show that you can do it based off of the username that you have set up. I'm doing it a little less secure right now because it's just for the purpose of setting this up. I don't want to go into a whole bunch of extra security settings and things like that. So I'm initially setting everything up using the root user ID. And then I also don't set up SSH, not SSH, HTTPS and things like that to help simplify kind of setting up your first project so you can kind of test. And then from there, you'll be able to see what you do when you load up an application and things like that. So you can actually have a BOINC test server running within about 30 minutes or so. And you can do stuff from there. So pretty much I've changed the remote.ini file, and everything should be set up in the YAMLs to go through and process everything. So all I do is I press the button, enter, and Ansible will go through and do each individual task in sequential order of how I have it set up. So the first ones, like I said, it's going to start doing the packages. So it's going to go through and install, Git, C++, other things like that, automake, all the requirements that are needed to have a BOINC server running. Also a few requirements so that you can actually compile BOINC as well, like the science application. I call it a science application. It doesn't have to be science. It can be math or whatever you want. So anyways, so that server BOINC 13 is actually going to run, and it will run in the background here. We can check in on it periodically if we want, but it is currently trying to set up and be similar to the other servers that we already have set up. So, it zoomed out. Zoom back in. Okay, so for everyone here, the login is BOINC to the server, and the password is workshop 19. I didn't change all that because I just didn't get around to it. So I posted that in the chat. You should be able to see that. You should be able to SSH directly to either boink11.uplinger.net or boink12.uplinger.net. And so you can, I think we have 3 people, so 2 of y'all may need to share, or someone can just watch along with what I'm doing on my screen. BOINC 10 I'm going to use so I can show you what the different commands I'm running are going to do. Does anyone have any questions up to this point? Or would they like any more explanation? I can't hear you, Michael.
I didn't say anything.
There it goes. Oh, okay. It showed that you were trying to talk on the chat thing, on the chat window. It says talking Michael. So sorry. Okay. So then I'll go ahead and start going through the PDF that I showed you, or that I sent earlier. The PDF basically will show you how to run a BOINC project, some of the initial steps to get it going. And we'll just run through these kind of one by one. I'm going to minimize my chat window because it's in the way. So the first thing that we're going to do when you have BOINC, so at this point, the Ansible scripts have completely run. Everything is completely installed. BOINC is ready to go. Everything is in place and how it needs to be for you to start actually working with BOINC server components. So the first part that you need to do is you need to describe which project, what the project name you want to have. So in this example, or the easiest way to do that is to change your directory to the project/test. That's where I put everything. Again, the Ansible scripts, you can change all that how you want it to be, where you want the directories, things like that. But right now, for this example, this is where things are at. So what it does is the tool called xadd, which will create the initial database inserts into the app table for the project that we have. BOINC here uses the project.xml file, and I've just catted it so you can see it on my screen. What it does is it produces a platform class, and then it also produces the app name that we're going to run. For this example, I'm going to be creating one called nqueens. It's just a simple mathematical trying to figure out how many queens are on a board. But what this does is it tells me I can have one version of the application running x86 on Linux. I don't have any examples right now to compile for Windows or things like that. But if you had a Windows, you would you would add a platform into this projects.xml, and you would just run bin-/xadd again if you modify this file to add additional platforms. So what we're going to do is we're just going to run bin-xadd. Pretty simple. It comes out with 2 lines. It says add platform here, and then the application was created. So within this, if you ran this again after adding another platform or another application, say you wanted one to do end nights, I guess is another question, or whatever your application is, it would basically say added app this. If you had the previous definitions in there and you ran xadd again, it just lets you know that it's already there in the database and it just skips it. So xadd is pretty nice, pretty simple. It goes along pretty quick. So now that we have the application added, we need an application. Like I said, for this example here, we're going to be using the nqueens problem. I put a link on the PDF to the 8 queens puzzle question, so you can read more about it if you want. But nqueens basically takes that and says your chessboard's however large n is, that's how large your chessboard is. So with the Ansible scripts I sent earlier that push copy files earlier, we'll go to this directory here within our server, and we'll just run a quick little command to compile. So we'll go to the build directory, we'll run cmake just to go through and get it to compile to prepare all the make files, and then we'll press make, and it'll compile the 2 files that I have in there that need to be written. If you were curious what an application looks like, you can go in and you can check out the main.cpp of this one, and you can review what's inside of the application. You can make changes to it. You can do whatever you want if you feel you'd like to. All this will be, like I said, I'll provide it all in the future, but it makes life easy just that it's here and it's just a sample. So now that we have a version, this was, like I said, compiled as for x86-64, and the systems that we're running on are x86-64. What you can do is you can just run the end queens actually directly from the directory where it was compiled, and you can see what the results are. So one thing it does once it's when end queens runs, it creates two files. For a BOINC application, it's good to have a standard error.txt file because what BOINC does is it will actually ship whatever's in the standard error.txt file. It will ship that back with when a client returns the results, and you can use that standard error.txt file and look up how the application behaved in the database. So for our case, I put in here pretty simple progress, how far it's going, and how many solutions it found at the very end here of 92. So that's pretty simple of a standard error that you can put in there. You'd like to not put too difficult because BOINC in the database doesn't allow standard error outputs of greater than, like, say, 1 kilobyte or something. So it's very limited in size. So if you have too much output in standard error, a lot of it will get cropped off. For our application, it also does an output to a result.out file. This is what we'll actually get back from the science application. So if we were running, say, AutoDoc, it would actually be the XML scoring of the targets and ligands and what they would do. In this case here, we're basically returning back some seed values, and then we're also returning the 92 is how many we got back from this one example, or from this one single run of end queens. So if you're curious, 92 is the answer to the number of queens on a 8x8 regular size chessboard. You can find 92 different answers, 92 unique answers. So any questions at the moment? Okay, then I'll go down just a little bit further. Like I said, I did not make this 100% secure. There are things from this example that you can do that will actually enhance the security of your application and your server that you are running. The one thing that is very critical, in my opinion here, is the code signing process. You will want to use an air-gapped computer. If you are not familiar with that, please look it up. Basically, it's a computer that has been never connected to the internet. You're able to actually use that type of that computer to bring the executables in, compile, and then, or not compile, but sign them and then move them off. A great way of doing this is to basically remove the hard drives of a machine and run a live CD of Linux. We use at World Community Grid, we use Ubuntu to do this, which is pretty simple, and it makes life pretty easy. So now that we have our binaries compiled, and I've explained that the way I'm doing it right here is not 100% secure, is we'll actually go sign the code and get a signature file that will help prevent hackers and things like that from stealing, basically being able to input a binary file to the end client. And if it's not signed properly, the BOINC client will say, I do not like this application, and basically throw it away. It will not run an application that is not signed properly. This will sign your application properly. However, it is not the most secure way, because if this machine that we have, BOINC 10, BOINC 11, all those servers, they are accessible to the internet right now. And if someone were to get in and use those machines without our knowledge, they could sign a new binary and then distribute it to your members. That's where the air-gapped machine comes in. So, like I said, we'll go to doing this step, and to make life easier, I'm just going to copy and paste the command. You're more than welcome to do so. But when we set up BOINC originally with Ansible, it creates this sign executable application, and then the commands that are actually being run is it takes in the application itself, which is this application bin and queens, and then the next part of it is the keys and your private signing key that you have. The private signing key is actually on the server, so you can see it there. And then what we do is we just take that output and we put it into a .sig file, and that's how BOINC will be able to process that going forward. So, and actually, while we just finished, I'll do this real quick. Yeah. Oops. Nope, I didn't copy and paste properly. Queens build bin. Queens. Let's see. There we go. And while we were waiting, while we were doing all that other stuff just a minute ago, our Ansible script is actually finished. And if someone wanted to, they could actually log into BOINC 13, and that server is completely set up the same way the other 3 servers are set up. So, oh, Matt's sending a message to everyone. Okay. How do I close it? Oh. So now that the application is signed, what you'll want to do is you'll need to copy the application into directories, and so that these directories that I have set up in the BOINC project, it's broken down into apps, the app name, the version number that you're running, the type, the platform, and then the actual application name. So with this, there is the we'll copy the bin, BOINC, and bin and Queens into those directories specifically. The naming matters, as you'll see, because when you increase to the next version, you'll want to change this 1.0 to 1.1 or whatever else. And then the same thing here, you'll want to change that to the next one as well. So all of that is very required and very needed. Version control is very good to have, and that way you'll be able to tell your members which version they're running. They're able to tell you that back pretty quick. So I don't know why the PDF doesn't let me copy and paste a single line, but it doesn't. So we'll just do copy and paste these in to save typing. And then, so if these directories don't exist, the nqueens one and then your platform, you'll have to create that for your next version. I believe in my Ansible scripts, I set this first one up for you. So we didn't have to actually make the directory, but it is something that you would have to do. You have to, and so say we had a Windows version. In here, you would change this from being x86-64 Linux. You would have it as the platform name for Windows. And BOINC has, I think I put a link on above about platform names and the standards that they use for that. So all of that is there. So now that those have been copied, well, now what we're going to want to do is there is a file that is also needed within those called the version.txt file, XML file. And this file here actually describes what you're loading, what it is, and then BOINC will actually be able to use that in the database once it updates the app version. It'll take this information, digest it, move files where they need to go, and then actually create the XML that gets sent to the members end machine when they go, hey, I'd like to have a work unit from your application. So we'll take a look at what this one looks like here. This is a very simple one. It has the version as the outer tags of the XML, but inside it has the physical name of the file. And then I have to describe which one's your main program. You can only have one of these tags inside of this, inside of the whole version thing. The version XML. The reason why is that BOINC will use that main tag as an identifier to say, when I'm starting up this work unit, I need to run this binary to actually operate the application on the end user's client. You can have other files. Say you wanted to also include a screensaver. In here, you would have file tags with a physical name of where what your screensaver binary was called, and then instead of having main program, I think it's graphics executable is what you'd use. But all of those are described in the wiki page that's posted on the PDF on how to do that. In this example, again, trying to keep it very simple, just so we can get it going. So anyways, so now that we have that, what we're going to actually do is we're going to load the application into BOINC. And like I said, this is taking that XML, the files that we created, the signatures, it makes sure that everything is as correct as it should be. And that way it's in the database, so when a person queries into the scheduler, they're able to get all this information from us. So it should give you a very simple output here. It says, is this the application that you're actually meaning to load? If it isn't, you can click no and it ignores it. Say you wanted to only do Linux version 1.0 and you wanted to do Windows 1.1 or something like that, you could do that also. But for us, yes, we're only loading this one and we know it is. And it was successfully added in as ID number 1 on the system. So any questions up until now? Am I going too fast for everyone or too slow or? Okay, I'll take silence as we're going. I'm sorry, go ahead.
Just fine for me. The speed is, is fine, yeah.
Okay, yeah, and like I said, you're more than welcome to follow along on your machine, or you can speed up. Some people are a little bit faster than I can talk and go through the descriptions. But we'll go through the next step here. The next step for running a BOINC project is loading a validator and simulators. What the validator and simulators are is that when your science application is running, the end users, the volunteers will send you your results back. These results need to be validated in a way that makes sure that they're not sending you back garbage. It depends on the application, how you want to verify that these are correct. So there's many ways of doing this. One is doing a bitwise comparison, saying that the answer from machine A and answer from machine B match identically. Every bit in the file that they upload to me matches one to one. Sometimes that is not possible, and you have to do other things like saying when I'm reading in the result file, I have to actually do some comparisons, some sanity checking of what's in the result itself. So you wanted to say that all values of this file should be less than 5. You can go through and read the file and basically do a parsing of it to make sure it's valid. The simulator, what it does is once a working is considered valid, it will actually take that results and it does basically a packaging up. You can do various things. You can just say, okay, the result of the valid results, I'm just going to copy and paste into this one directory over here, and that's all I want to do, and that's how that's all you need. There are other types, you can do more with it. You can basically say I attached 10 files, I can cat them all together at one point. I want to split them all up, and so that way when I save it into the file structure that your researchers or whoever is looking through the results, it's in an easier to read format than the way BOINC uses the naming. Excuse me. So all of this is two major parts of the BOINC system that are behind the scenes. Your members will see the validators. They'll see if they're not up to date or if they're not being kept up, and usually they'll tell you about it. The simulators are usually behind the scenes a little bit further. If your simulation is behind, the members don't usually worry about that because they've already gotten their points and they've already proven that they've done valid work for you. So to that extent, though, for this purpose, I put some sample validators and simulators in the directories below under application daemons build. And so we have a few files here. We'll take a look at those. So, no, not build, sorry. Up one directory from build, I created a few simulators. So I have one that has a simulator cleanup seed. I'll show you that one later. And then just simple simulator, which is just copy paste, I think. And then I have two validators here. One is the bitwise check, which means one-to-one matching of the results. And the other one is basically, I don't care what the results come back. I'm just going to call it valid. It's a very simple validation. So, I mean, in the validator, you will need to put, this is, like I said, this is a very simple one. You will have to have distinct functions in there, as BOINC expects these after you compile. But one of the main one here is the init result. What that does is when a result is actually says it's ready for validation, BOINC will call this function here, and it will go through and actually compare and see if the initial part of the result is good. You can do validation inside of that of, like I said, if you wanted to say the results can't have more than 10 lines in it, or I expect the third character of every line to be the letter C. I don't know. You can do quite a bit in there because you're just reading a text file or the files that come back, and you're doing some sort of review of it. Once the validator says the initial part of the result is good, and if there's two of them to compare against each other, then what it does is it takes the compare results and it will compare those two together and return back if it's a match or not. Like I said, this one is basically stripped down to nothing, and all I say is that if I have two results come back, return it as true, and so there's no checking. You can have one return garbage and one return the right results, or both return garbage. So to that extent, we will go in. Let me go into the assimilator real quick here. We're going to be using the simple assimilator for the first steps of this. Again, it requires some specific functions from BOINC, and then what it will do is it will go through and process it. So let's see. I think what I have here is that I make sure that the name is correct, and then I basically print it out and create the file name. So it's pretty simple. Not much more to this. So there's sorry, it took a little bit to scroll down. Here is where it creates the file name, and it put where I want to write the results to. And then what I do is I take that result.out file that was created from the volunteer, and I paste it. I basically save it to a directory. So very simple. There's some error checks to make sure that things are, if they don't pass, it returns valid simulation error, things along those lines. In your assimilator, you will want to have some of these checks here just to make sure that if for some reason it gets to too many results, too many that couldn't be sent, things like that, that you can mark an entire work unit as invalid because it became too much of an invalid state. But these are, like I said, they're pretty standard. Usually this just sits at the bottom of the file. So we will go ahead and we need to compile all of this. So we'll go through and make the CMake file and then build. There we go. Compiles all four. Like I said, I created 4 of them. We're only going to use 2 at a time. But now that the binaries are created, what we need to do is we need to copy and paste them into our projects directory under the bin folder. And that way we can use it there easily. BOINC expects them to be there. That's where they expect these files to be. So we will go ahead and copy paste. Very simple. Okay, so now that we have those files created in the right location, what we need to do is we need to tell BOINC what they are and that they're supposed to be running and things along those lines. Up until this point, nothing on BOINC has been running on your computer, on those machines. The feeder, the transitioner, none of it's been running. Everything that, even though BOINC has installed the projects created, if someone tried to attach and try to get work, it would say there is no scheduler available, and it would return an error and basically say there's nothing to send. So all that definitions of everything for your entire project is in this config.xml file. It's a very important file. There is more definitions to it. I didn't have a link on this thing, but on the BOINC wiki pages, there's more details of what you can configure and what you can change through it, which is really powerful and really cool. So for this purpose, we're going to just take a look at what we have. Oops, new file. Oh. I'm in the wrong directory. Test. There it goes. Okay. So in here, you've got a bunch of commands, is what I'm saying, a whole bunch of different options that you can set for your server, and then various, upload, download keys, things along those lines. But for us, for this part of the example here, we are going to be messing with the daemons. The daemons are supposed to be running 24/7. They will run nonstop until you tell them to stop, or your server turns off. They have sleeps built into them, usually 5-second sleeps, but some of them don't. But they are here. This is where they're defined. Again, in this example here, what we're going to start out with, we are going to just copy and paste. Oh, this is not going to work from there. Let's see if it works from here. Nope. I'm probably going to get some line failures. So we'll just copy and paste and add these in here for the daemons. It didn't work at all. Hang on. I'll just clean it up real quick while we're on the call. So the first one that you have on here, the feeder as D3. D3 means it's a debug. It's a very standard thing within the BOINC software. You can change that down to 2 or 1, or even go to 4 if you wanted to. What that does is in the logging, and just how much gets printed in those logs. The feeder itself is what the members communicate with. It's a shared memory segment of what's available to be downloaded from the BOINC server at that current time. The transitioner is kind of your state machine of the BOINC work units. When a work unit gets sent out, it waits for a certain amount of time. The transitioner has a timestamp on it, and the work unit has a timestamp on it, and the transitioner waits for that timestamp to come back. If someone returns the work unit before the deadline is up, the transitioner gets triggered that work unit needs to be validated, and it will automatically trigger it to go to the validator and things like that. Basically, it figures out where in the stage of the work unit's life cycle it is and helps progress it to the next one. And that way nothing's stepping on each other and nothing's having to search through the entire database. It's only looking for specific items. The file deleter is pretty simple. Anything that's been completed gets deleted after it's done. After it's been assimilated, it deletes it from that directory because you no longer need the data. It'll delete both copies if you have more than one copy of the result that gets sent out. All of that gets cleaned up. So the two that we are adding the validator for no check. Like I said, I have in here a sleep interval of 5. You have to have the application that you're running it against. And then I like to always grant my members credit, even if they give me something invalid, because, and this means I'm granting them 100% credit. Sometimes it's not their fault that the result is invalid, and I like to err on the side of the benefit of the doubt for the members. So anyways, but that's very simple command lines. There's more command lines that you can add to it, but those are generally the ones that you would use. The assimilator is simple. That's the one we're going to be using. And as you can tell, these are the binary names that we copied in. So you can change this to whatever you want if you had different ones. Again, debug, sleep, and the app name for the assimilator. Now that we've added that to the config, we'll save it. And pull back up the big one. Now that that's done, what we'll do is we'll actually check out the status of it, see where things are. So if you do a bin status in that directory, in your projects directory, you will see now that we have the daemons listed. And it all says that they're disabled, no, so they're unlocked, they're not running. Nothing is running. BOINC is disabled, everything's turned off. So from here, what we'll do is we'll just run a bin start, press enter, and it'll start the daemon so that they're ready to go. And then it gives us some feedback. If we go back to status, you'll see that all 5 are running and they're locked. They have a PID associated with them, so they're all ready to go. And they're all just running. You can check out the logs. You can see what the scheduler is trying to say. Well, it's not going to say anything because we haven't had anything turned on. So let's see, we'll go to the logs. Yeah. So the validator, simulator one, very simple. It just says he started, there's nothing going on. He's waiting every 5 seconds. He's going to queue the database to see if there's anything that he needs to assimilate, things along those lines. But if someone were to try to attach to our BOINC project right now, what they would get back from us would be, there's no work available, but the project is up and running. They would get a successful BOINC query. So you can run bin stop. That'll stop everything if you wanted to. At this point, we'll be fine to keep it running because that's what we're going to be working on next. So any questions up to now? Okay, I'll take that as a no. We'll go on over to the next step that you'll need to do in BOINC is to create work units. The members like to have work units to crunch through. So what I did was I created a nice little script that goes through and creates some work units. I have it with batch name and size. The number 12 is the board size, how big it is. Instead of it being an 8x8 board, this one's a 12x12 board. And then how many work units I want to create. I'm creating 10 for this example. So it's a very simple script. It has some fun in it. If you wanted to take a look at it, you're more than welcome to do that. But for time, we're going to skip that part of looking at it. And we will just go ahead and just run the create works command. So for this, I call everything a batch. I give each, when I create work, I create them in batches. So this one's just called batch 1. I like to have those as being unique. It helps with when I create the next set of work units. If I create another group of 10 work units, I'm using the batch 1 as the initial identifier of the work unit name. And then I create, it's called, basically the work unit names will be batch 1 _0 _1 _2. Very similar in progression. So, and like I said before, I did not worry about security, so you'll get warnings saying that using a password in the command line is not secure, but that's what it is. So that'll create work units, that'll put them on the queue for your system. So then the next thing that we'll do is we'll actually go make sure that it is actually on your on that system that you have. So we will go log in on the browser. You can actually go to your specific project. So for your example, it'd be BOINC 11 or BOINC BOINC 11 or BOINC 12 under test ops. And it will pull up to see what your username and password is. Your username and password is BOINC and 2019, and then workshop 2019. So behind the scenes, this is what not many members get to see. This is the project management portal. It gives a little bit of a web interface of interacting with things, doing some simple queries, some very common tasks that you can do. You can look at browsing the entire database by who's a host, users, a whole bunch of things. For this purpose, we're just going to be using the results for N queens, and we're just going to look at the summary of it. And in this example here, we've got 20 work units that are unsent. Nothing has been sent out yet, which is expected. We have to have our BOINC client actually do a query against, or basically a BOINC client has to pull work for them to go into a state of being in progress. So for that purpose, I'm going to, on the server, which has a BOINC client installed, I'm just going to issue an update command for the project, and that'll actually force it to try to force it to the server to say, hey, I need some work. And I'm just gonna, each of your servers are attached to the other two servers for BOINC. So you should be able to do the update command to all three projects and get the work from there. But for you guys to see, I just had mine do it to all of them. So if I refresh this page, we see that now one is in progress. You can click on it, and you can see who has it, host and user, BOINC 10, has that working, it's in progress, it's running. So pretty simple. You can see that if you went to the unsent, click the number, you can see which ones haven't been sent out yet, and it just gives you some extra things. Oh man, we got 5 minutes. Okay, I better hurry up. So anyway, so that's we can see that things are working right now, that we've got 2 over and 1 in progress. So it's just going to progress through and churn through these work units, which is nice. So I was hoping we get one back as to go through validation. There we go. So on this over here, you can see under the success, we have initial of 1, 2 are valid, which means because I have the 2 comparing against each other, both of those are in a good state right now. So go back to here. So now that all of that is done, you can actually go to the server, to your project directory. And you can actually, now if we looked at the log for the feeder, or not feeder, validator, we can see that what it did, it printed out what it was doing. It said, hey, I've got results. Someone wanted some amount of credit, and this is what we gave them. And then it just basically goes through and says, okay, cool. So we're done with that. It makes it real simple. If you went to the log for the assimilator, that was running the simple assimilator, it'll tell you where your result file is. You can actually go in, and this file you can actually, no, not that one. Go into the directory where you have it writing it to. And you can see that batch 5, that specific one is out. And so you can see that that was the answer. An N Queens board 12 by 12 creates 14,200 unique results. So since we're running out of time, I am going to let you work on it, let you do whatever you want with the changing the validator into another one or loading more work and things like that. But you can also test various things I have on here. The bitwise validator is something that you want to change to. And then you can actually, with the create work script that I created, you can actually force it to tell them to give you, basically tell the application to produce invalid results. What that does is it prints random numbers inside of it, inside of nqueens when it runs, and you'll be able to go through and see in the logs what happens. And then you'll, in the test ops page, you'll see here that you'll get some invalid and things like that. And then you'll get more excitement other than just initial invalid coming back on that page, and you can go in and dig in and explore. So for this one here, you can actually dig in, and this is the details on this results. And this is the standard error that I was mentioning earlier, that if you have that file standard error.txt created from an application, it will actually upload that back to the client or up to us, and we can actually see what it ran. So you can see the options and things that changed, and then progress as it went through, which was updated on the client as well, and fun things like that. So let's see, since we only have a few more minutes, is there any more questions or any questions that anyone has? Or well, I was almost to the end. The last bit was just messing with the invalids and checking things out. So does anyone have any questions or anything, any comments? Let me pull up the chat so I can see if anyone has anything in the chat. No. Okay. So does anyone have anything that they'd like to add or discuss, or anything any questions about any of the steps from either the start to the finish? More than happy to answer anything you got.
How is the way to to give some input files to the worker.
Oh, to send to add input files.
More complex, yeah, more complex data than just the 12 by 12 board or something like this. Yeah.
Okay. Yeah. So so in this example here, I'm going to pull up my create work. Should show. No, that doesn't have it. So yeah, here it is. So in the create work shell script, there is the command to the BOINC create work part. So what I did was I just created a loop that went through to it. What it needs from you to add work units into the database is actually needs the application name, the batch ID, which is what we created uniquely, the size of the, and then it has the command line. For this example, I just, in the command line, I put the size and the seed and the invalid option. That's all that was needed. But if you wanted to actually change what you wanted for more input, you would go in and it has a result template that this file here, it's in your projects directory, will show what files you want back from the client. So you can actually specify what you expect back. And then it has the work unit template, which is also needed. And this will show you what is sent to you. So I'm actually going to cat this real quick. So we'll go to the projects directory, test, and we'll go into templates. So in the input, we'll pull this up. It has the work unit name and then what it has in it, but then also after this, you would basically add a few things like file reference. I think it's there's a wiki page, but it's like file ref, you know, and you add the name and things like that. I'll get the link. BOINC. How do I spelled work unit templates? Work unit generation. So this is the link. This has my internet work. No, where is it? Usually they have. Hang on. Job submission. Here it is. Input template. So these are, here's the link. I'll post it into the chat for you. So in here, it shows more information about what is needed on the work unit template. So it has the file info. You do one for each file that's needed. The URL you can add in there where it needs to download from and things like that if you had it on a CDN or anything like that. The physical name, various options, which make it easy. The one thing that you will want to do is you want to put the checksum and then the end bytes also, so that way when it sends out to the members, they can it'll verify with them. But this is the work unit template here. And this needs to be sent with each work unit when you do a create work submission. For our example, it was just a very simple. I didn't worry about how much memory was needed for a work unit, but all of that is given in that input template. How many errors you can have, things along those lines. To the same extent, the output template that you give to the create work script, it should be just further down. It has very similar stuff that's needed, where you tell it, I need an output file 0. If something is created on the client that you want back, how big the file is, when you want, how long you need it, when it needs to come back, and things like that. You can actually set files as optional if you don't need them all the time back or if you don't expect them. But both of those XML templates are required for the create work submission. We're getting told we got to leave here in a minute. Okay, hang on.
Thank you. Yeah.
So, but at the end of that create work line, it has the work unit name and then the batch, let me highlight this. It has that part of it, the work unit name and batch. Right after that is where you would give it the individual files that you were including for that work unit. So say you had file A and file B, your end of your script, you'd have two space file A, space file B, and where those files are, you know, like direct locations of where those files are. So does that answer your question?
Yeah. Yeah, fine. Yeah. Thank you for the session.